Okay, so again, my name is Kristin Conte. I work for Manchester Waterworks in Manchester, New Hampshire. I'm a laboratory technician biologist over there, and we're lucky enough we have 3 full-time people in our lab. Just a little bit about Lake Massabesic. We've been providing drinking water since 1891. We serve approximately 160,000 people in Manchester and 6 surrounding towns. Our treatment plant pumps on average 18 million gallons a day. In the summer, we've seen up to about 35 million gallons of water a day. We have the gross storage capacity of 15 billion gallons. Lake Massabesic is pretty much 2 separate ponds connected by a channel. Just a little bit of background there. When I was talking earlier, we have restricted recreation on our lake. We don't allow swimming or any sort of physical contact with our water. We do allow boating in monitored areas. We do have some restrictions there. So our lake monitoring program, from what I could find in the archives, we started, or people in Manchester started collecting water quality data back in 1996. But then in 2004, which happens to be when I started working there, we started monitoring on a more consistent basis on 8 different sites around the lake. So we've already had an established lake monitoring program out there. So not only did we have the staff, but we had the means, we have boats and the equipment to do so. And our goal was to get out weekly, but sometimes, you know how things go, we have other things going on. So it was usually weekly to bi-weekly, nothing more than that went by. And why should drinking water sources monitor for cyanobacteria? We monitor for so many different things in the drinking water world, in our finished water and also our source water. But this is a whole kind of new thing into the drinking water world. First of all, it reduces threats to water quality. By observing the water conditions, weather patterns, and collecting data, the better we can understand our possible dangers. And we can also detect increases in cyanobacteria activity. This also helps us to develop effective treatment responses. I touched a little bit upon that before, because not only do they pose threats, like a lot of you are in watershed associations and you deal with recreational issues, we're also dealing with public health ingesting things, maybe issues. And response plans can also help optimize your treatment during a bloom event. So sometimes drinking water utilities have different intakes that they could switch intakes, so to say, into a place where they're not seeing a bloom, or prepare your treatment. You know, you might have to be adding a little bit more coagulant into your flocculation process. And you can also, I have been working with Nancy as well, with some prediction things going on. You can also predict potential blooms for a more efficient response. So once you have those things established and know kind of what your utility is capable of, you can kind of get those steps going before maybe you even see a bloom. You can also collect baseline data to acquire a greater understanding of your system and your drinking water supply. This is probably the most important piece that we gathered through this whole process in 2016. We really got a great understanding of our system as well as trends in our system and regionally. So the materials we use, here's one of those cyano kits that Nancy was talking about. We have a fluorometer, calibration standards, cuvettes, all the things that go into the kit, the integrated sampler, tube sampler, we got a net, all these things, our little zappers here as well, and also a boat. Like I said, we are fortunate enough to have a boat fleet over in Manchester. Some people who don't sometimes can sample from a dock, as well as Nancy has developed a whole other apparatus that you can actually hook onto an intake tap that you can sample right from your tap at the water treatment plant, from your source water. So this is Lake Massabesic, as I was talking before. It's kind of 2 separate ponds surrounded by a channel. The way we chose our sample sites for cyanobacteria, obviously we wanted to sample near intake. That's the greatest concern for us. The other spot being Front Park, that's our deep spot on the lake, as well as over at Claire's Landing, which is the main boat launch, and also where our main inlet comes into the lake. So those are the 3 reasons and 3 places that we chose to monitor on a regular basis for cyanobacteria. And like I was saying, this was just a little bit on top of everything else we were already doing, which included dissolved oxygen temperature profiles. We did some in-lake sampling, things like that, CT disk clarity. So a lot of times, like public drinking water utilities, like we're fortunate because we do have the staff. A lot of people don't have the staff in this field to be able to support such a program. So when you try to bring something new upon people, they want to know how much time does it take? You know, how much is this going to cost? These are things that are of concern. So I kind of put this together for us because we have 3 different sites. It added only maybe 30 minutes to our sampling events. Sampling does work best with 2 people. And then it's about an extra 60 minutes back at the lab for our fluorometry processing. And we also do a lot of fractioning of our samples because we also participate, as I was saying, in some research projects as well. So we have a little bit extra there. The obstacles for water suppliers, like I was just talking about, is funding. Obviously, materials are always at a cost. Sometimes it's difficult to work within those government budgets, which tend to be very limited when you're trying to establish new programs and purchase new equipment and maybe training. Time. Sometimes, or a lot of times, we have limited time to be able to put towards this thing and to implement new programs, as well as, you know, that's kind of goes along with that, personnel and interest. Sometimes smaller systems do not have the staff to support such a thing. So I see a lot of great volunteer groups here today, and that's really where that could be of advantage, or people can use that interest with your stakeholders and maybe watershed groups. So some tips and key points. What I did years ago, like 5 years ago, was utilize a source water protection grant through the state of New Hampshire to purchase the equipment being used. The state of New Hampshire now, NHDES, has developed a new grant that's specific towards cyanobacteria for water utilities. And I think everybody, is it just water utilities? Is everybody? Yeah. Okay, so that's a great financial assistance to be used. Join this work group or other coalitions to, you know, learn about monitoring, keep up on current developments and regulations. This group has been a great resource for us, so I really think it would be great for other people. Also, start monitoring your source water to gain that baseline data and to really see where your system starts off at, you know, and then you'll be able to see trends, and that's been really important to us. And also have a plan in place in case this does happen, because it can happen to everybody. We've seen trends across the region. Like I was saying, with the warmer climates, we've seen a lot of heavy precipitation events and seasons that have really given us some nutrient loading and cyano blooms across the region. So I think it's important for water utilities to have those responses in place, like the phone numbers of people who to contact at your state departments, even federal departments, things like that. So our future directions, we borrowed a sonde from DES this year, and we're interested in perhaps purchasing our own. I might be writing another grant this year, trying to get money to be able to purchase one of these, just because this is going to take in-lake monitoring to another level. Consistent data collection readings, including chlorophyll and phycocyanin, would be just another tool that would be really great for us. Any questions?
Thank you.